online workshop on advanced statistical data analysis using SPSS. Hope you have all enjoyed these 6 days of learning. You have all your doubts and queries have been sorted out by the resource person. Because we have some limitations due to the time restrictions and other things. So, but yeah, at least you have got some idea how you can do the analysis for your own purpose, not professional, but yeah, at a beginner level you can see your research. So with this, now I would like to invite our today's team resource person, Dr. S.K. Yadav, sir. So welcome you, sir, once again.
Thank you.
And so sir will take the session on the discriminant analysis. So over to you, sir.
Okay, thank you. So very good evening to all of you.
Good evening.
Good evening, sir. Good evening. How are you?
Fine.
So today is the last day of the workshop. So very good evening to all of you, and I hope you have enjoyed, and today as well you will enjoy, and we will be discussing the things and we will be learning a lot. So let me share the screen.
Yes, please share now.
Is it visible?
Yes, sir.
Okay. So yesterday we were talking about the cluster analysis. So there are three areas, very important multivariate techniques: factor analysis, cluster analysis, and discriminant analysis, or sometimes we call it as canonical discriminant analysis. So what we have done, we have learned that if we are dealing with many variables and many of them are of similar type, then there we apply the factor analysis, the very famous technique in factor analysis, the principal component analysis, to reduce the dimensionality, and we make the group of the similar variables and we name it a new variable known as principal component. And if on the basis of different characteristics we wish to group the units, then this is the case of cluster analysis. But in cluster analysis we don't know how many clusters are to be formed. We don't know which unit is going in which cluster. So it is done on the basis of the similarity, and the similarity measure is their distance. So how it is different from that one in this discriminant analysis? It is also very famous with the name that it is a classification problem. So here we know the classes or say clusters in advance, and we make some discrimination function. On the basis of those functions we put different units in different groups classified already. So this is the difference in cluster analysis and say discriminant analysis. So discriminant analysis is a classification problem, as we just were talking about, where two or more groups or clusters or populations are known a priori, they are known in advance, and one or more new observations are classified into one of the known populations based on the measured characteristics. So on the basis of the characteristics, we put the observation in the appropriate class or appropriate group of, or appropriate cluster. So in discriminant analysis, the dependent variable is a categorical variable. So maybe having 2 category, 3 category, and that's. So here we may say like that, and whereas independent variables are metric, that is quantitative, numeric. So here dependent variable is non-metric while independent variables are metric. So this is we may call that multivariate extension of say logistic regression. So discriminant analysis is sometimes also known as discriminant factor analysis. We also call it as discriminant factor analysis and or canonical discriminant analysis. Now, what is the purpose behind this study or this technique? The main purpose is to classify a subject into one of the 2 groups, 2 or more, maybe more, on the basis of some independent traits, that is independent variables or independent attributes, characteristic. Not attribute, actually characteristic, because here we are taking the independent variables as the quantitative one. So here we have to classify the unit or object on the basis of the independent variables to the classified groups or say clusters. And the second purpose is the second purpose of the discriminant analysis is to study the relationship between group membership and the variables used to predict the group membership. It means we are wishing to establish the relationship between the dependent variable and the independent variables, and here the dependent variable is a say membership function or say grouping function. So we have to establish the relation between the two, the categorical variable, which is dependent variable, and independent variables, which are metric or say quantitative or numerical variables. Now, this is the objective. These are the objectives of discriminant analysis. That is, the first thing is to develop the discriminant function, because of that we are able to, I mean, discriminate the things, or we are capable to know that in which class or group the particular unit should be placed on the basis of the independent traits. So examination of whether significant difference exists among the groups, it also enables us to know whether there is a significant difference between different classes or groups or not in terms of the predictor variables on the basis of the independent variables. And the third objective is that determination of which predictor variables contribute to most to the intergroup differences. Which variable is responsible or say it is contributing much to distinguish between the two classes. And definitely evaluation of accuracy of classification. And definitely we wish that this discriminant function must be a very efficient function. So it is also the objective of the study to evaluate the accuracy of the classification. Now these are the applications of discriminant analysis. It is applied to identify the characteristics on the basis of which one can classify an individual as. We are capable to distinguish the things, discriminate the things to be classified in different classes. For example, the basketball player or volleyball player on the basis of anthropometric variables. High or low performer on the basis of skill. Junior or senior linear category on the basis of the maturity parameters. So on the basis of the quantitative independent variables, we make the discriminant function for which classifies different objects or say units to be associated with the different classes. Now these are some assumptions for applying this discriminant analysis. The one assumption is regarding the sample size. So group sizes of the dependent should not be grossly different. It means if you are classifying the things, you are making the different classes, so there should not be a huge difference in the members of different classes. So here logistic regression may be preferred. And the sample size should be at least 5 times the number of independent variables. It means if you are using say 5 independent variable, then at least you have to take the observation on 25 units. 5 times it should be, the sample size should be 5 times the number of independent variables. And obviously, the second assumption is about the normality of the data, that is normal distribution. So each of the independent variable should be normally distributed. Now homogeneity of variances or covariances. So all variables have linear relationship. Linear relationship means if we are changing one variable, there is a constant change in another variable. So this way, all variables should have linear relationships so that there will be a homogeneity in variances as well as covariances of different independent variables. And there is one more assumption regarding the outliers. So outliers should not be present in the data. So discriminant analysis is highly sensitive to the inclusion of outliers. If outliers are there, so it is very sensitive. So it may misclassify the observation if outliers are there. Now mutually exclusiveness of different classes. So all classes must be mutually exclusive. There should not be any common observation or common unit in any class, any subgroup or any subpopulation or any cluster. So the groups must be mutually exclusive with every subject or case belonging to one and only one group, not in any 2 or more groups. And obviously the sixth assumption is that regarding the classification, each of the allocations for the dependent categories in the initial classification are correctly classified. There should not be, case of say misclassification at the initial stage. Now variability should be there. So no independent variable should have a zero variability in either of the groups. It means any independent variable should not be just like constant, because constant value will have only zero variation. So no independent variable should have a zero variability in either of the groups formed by the dependent variable. It should not have, say zero variance or covariance in any of the groups. Now these are some terminology for the discriminant analysis. The variables in the analysis are the independent entities, that is independent variables, and discriminant function. It is very important. 2 things. One, categorical variable, that is which is the dependent variable in discriminant function, and independent variable, and from both type of variable we make the discriminant function, and it must be an efficient one. So second thing is discriminant function. So a discriminant function is a latent variable. It is hidden variable, say, which is constructed as a linear combination of independent variables such that say z is equal to c plus b1 x1 plus b2 x2 plus 1 plus bn xn. where Z is the normalized one categorical variable. The discriminant function is also known as the canonical root. This discriminant function is used to classify the subjects or cases or say units into one of the two or say more if we are dealing with the more groups on the basis of the observed values of the predictor value variables. Predictor variable means the independent variable, these x1, x2, and say xn. Now the next one is the very important entity in discriminant analysis is the classification matrix. So in discriminant analysis, this classification matrix serves as a yardstick in measuring the accuracy of a model. So as I have already mentioned that we search for the more and more efficient model. So it is important to check the accuracy of the model. So this classification matrix is a yardstick in measuring the accuracy of the model in classifying an individual or case into one of the two groups or more groups as the case may be. It is also known as confusion matrix because it creates some confusion where to assign the observation, maybe case of misclassification and others. And so sometimes it is also known as confusion matrix or say assignment matrix. On the basis of the this matrix we assign the observations to different classes, or say prediction matrix as well. We predict in which class the unit should be. So it tells us as to what percentage of existing data points are correctly classified by the model developed in discriminant analysis. So definitely the efficiency depends on this characteristic that how it is correctly classifying the units, whether it is misclassifying some units or it is correctly classifying all the units in the predetermined classes of discriminant function through discriminant function. So stepwise method of discriminant analysis, we apply the stepwise method for discriminant analysis. So discriminant function can be developed either by entering all independent variable together. There are two ways to make this discriminant function. Either you add all the independent variables at once, just like this one here, or you start with one and you start step by step making this discriminant function. So here discriminant function can be developed either by entering all independent variables together or in stepwise, depending upon whether the study is confirmatory or exploratory. So as we do in factor analysis, if it is CFA, confirmatory factor analysis, there we apply the well-known clusters, well-known factors are there, we prefix. And if we are not knowing the factors or say classes, then we apply the exploratory factor analysis. So if you are not making different groups in advance, then you should apply EFA, exploratory factor analysis, and it will provide you the optimum number of classes there. And if you have idea, if you are fixing the classes, then you have to use confirmatory factor analysis. Now, power of discriminatory variables. This is very important. After developing the model in the discriminant analysis based on the selected independent variables, it is important to know the relative importance of the variables so selected, how they are relatively important for the discriminant function to identify the unit to the correct class. That is how it is contributing to the correct classification. So their box M test is there. We use for knowing this, say, variance covariances, equality of covariances in different groups of classifications. So by using box M test, we test a null hypothesis that the covariance matrices do not differ between groups formed by the dependent variable. If the box M test is insignificant, it indicates that the assumption required for discriminant analysis holds true. It means if the null hypothesis is accepted, insignificant means the p-value is greater than 0.05. So if the p-value is greater than 0.05, then the null hypothesis of box M test is accepted, and that is the assumption that the covariance for all the independent variables in all the classified groups are same. So it is done through the eigenvalues. So eigenvalue is the index of overall fit. So through eigenvalues, as we have seen in scree plot in factor analysis or say principal component analysis, we only make or form the, or we consider the principal components having the eigenvalues greater than 1. So it is just like scree plot is just like elbow type. So we consider only points from elbow, above the elbow. So these are having their roots greater than 1. So this is very important index for the overall fit. Now Wilks lambda, it is contrary to the coefficient of determination. Sometimes we call it as the measure of bad fit, as we call R square as the goodness of fit. Here we say that it is the measure of bad fit. So it means it provides the observations for the discrepancy between the observations. So it measures the efficiency of discriminant function in the model. So how it is discriminatory, how much it is capable to discriminate the things. So it checks the actually heterogeneity of the observations. So its value shows how much percentage of variability in dependent variable is not explained by the independent variable, while R square tells the how much percentage of variability is explained by the independent variables. So here it tells that how much is not explained by the independent variables. Now canonical correlation, it is very important. It is the correlation between the dependent variable and the independent variables. That is, it is multiple correlation between the categorical dependent variable and numeric independent variables. So the canonical correlation is a multiple correlation between the predictors and the discriminant function, and the discriminant function, not only the categorical variable, not only categorical, the whole discriminant function. So it is the multiple correlation between the z, whole the discriminant function, and x1, x2, xn. So with only one function, it provides an index of overall model fit, which is interpreted as being the proportion of variance explained. So that is why we see through say Wilks lambda how much percentage is not explained, or rest of the portion will be explained by the discriminant function. So this way we will be able to check the efficiency of the discriminant function. Now these are the simple steps for the discriminant function, or say discriminant analysis. In step 1, what we do in step 1, the independent variables which have the discriminating power are being chosen. We select the independent variables to be included into the analysis. And in step 2, discriminant function is formed. This discriminant function model is developed by using the coefficients of the independent variables. What we do in step 3, in step 3, Wilks lambda is computed for testing the significance of the discriminant function. We check the efficiency of the discriminant function through Wilks lambda. In step 4, the independent variables which possesses importance in discriminating the group are being found, which are important in discriminating the units. Now say here, say we are having an example. For instance, to identify a player into different categories during the selection process in a cricket training camp. So suppose here we are having different independent variables, say height, arm length, leg length, palm length, shoulder strength, reaction time, and some more speed, judgment, patience, and player. So here we are having this only categorical variable players. So this is going to be a dependent variable. Player will depend on these 10, say 10 explanatory variables. So these are, say, observations. So how we will perform it in SPSS? We will click on analyze, then go on classify, and there is a function or option of discriminant. So here discriminant analysis, you will see this dialog box will be opened. So you have to define first, here you have to put the dependent variable in grouping variable, which is categorical variable, say player, and you have to define the range. If you are making only 2 groups, then you have to put minimum 1 and maximum 2 and click on continue, and then go on statistics method, classify and save one by one. So here if you are going clicking on statistics, you will see here. So you just click on means, you click on box M method. We will check the equality of covariance in different groups through this method, and you click on Fisher's coefficients and unstandardized coefficients as well, standardized as well as unstandardized, and click on continue. Then you will see this function in classification. So you have to choose all groups equal and within group, because we wish the variability or similarity within group. And so what we wish to display case wise results, and we need summary table as well, and click on continue, and then outputs will be here displayed like this. So this way you can see here we are 2 types of player only in cricket, batsman and say bowler. And so these are the parameters, same parameters, and these are their average values for different independent variables, and these are the standard deviations. These are the unweighted numbers and these are weighted numbers as well. And this way, this is the summary table. Now here box M method is showing that the p value is 0.78, which is much more than 0.05. It means the your test is insignificant as we wish. It means the covariance in both the groups, that is player group and batsman group and bowlers group, have the same covariance. Now these are the coefficients, that is, since we are, if suppose we are using only 4 independent variables, so these are the coefficients. Say this one beta 1, beta 2, beta 3, beta 4 is this way. So here say we are dealing with the 4 variables only, independent variables. So x1 is height, and x2 is back's explosive power, and x3 is judgment, and x4 is patience. So, and these are the coefficients of the discriminant function. So this way this discriminant function will be formed. This is the interceptor, that is coefficient, constant coefficient, and this is unstandardized coefficient. These are unstandardized coefficients, and you may have some standardized coefficient this way. By standardization, shifting the mean to the origin, and origin to the mean, and dividing the by its standard deviation. So this way, this is unstandardized. You can have standardization is important to make these variables to put together in the analysis. Otherwise, the measures may affect these this discriminant function. So here you have to put this, say you have made this discriminant function on the basis of the 4 independent variable only. Now this is the summary of canonical discriminant function. So here we can see there is only one discriminant function, and you can see here this is the eigenvalue, and 100% observations are available there, and this is canonical correlation is 0.96. It means very high correlation between the discriminant function and the independent variables considered for the data. So for the analysis, and here is the Wilks lambda. Wilks lambda tells about the goodness of fit of the discriminant function. So here you can see here the value is 0.000. So it tells about the bad fit, and bad fit is rejected, that is the function is good fit. Now these are the classification result. So you can see here 20 batsmen, 20 bowler, and this is the table. Okay, so these are the standard. Now if you have standardized the independent variables, so these are the standard coefficient. For the standardized random variables, these are the standardized coefficients for the discriminant function. And this way you can have, these are the centroid, I mean average for all the groups, batsman and bowler. So you can see here these are the centroids are almost same for unstandard canonical discriminant function evaluate at group mean. So here you can see the they are both, I mean both are same for batsmen as well as for the bowlers. So this is very, I mean, short topic. So now we will be doing hands-on little bit after 5 minutes, and then we will be considering the questions. So I will take a break of 5 minutes, and then we will be discussing we will be doing hands-on, and then after that we will be discussing the queries and questions.
Hello. Hello. Dr. S.K. Yadav sir, you are unmuted. Muted. Please unmute yourself.
Yes, I have put on mute, but I am just explaining the hands-on.
Okay. Okay. Not an issue. Dear participant, please wait for a moment. Sir will come on.
Okay. So let me share the screen first and then we'll be doing hands-on.
Thank you, sir. Thank you.
This is the case with the 2 groups, and then we'll be doing it for the 3 groups as well. Okay. So here we are having a case studies of say purchasing of say bike. So here we are having these 3 independent variable and this one is dependent. Here we can say this is categorical variable and this is the potential buyer and this is the ability to buy this one, and this is performance of that bike and looking of that bike. Yeah, this way. So durability of the bike is one independent variable, performance of the bike is another variable, and looking of the bike is third variable. So we have taken I mean scores on say 10-point scale, or say here we have taken on 100-point scale. So the we have considered this data for 80 persons, and here are their outputs on 100-point scale. Now we'll perform the discriminant analysis here. So what we'll do, we'll go to analyze, then comparing. One more thing, if you wish to see whether so we have given codes for this one. So you can see here we have given one for I mean purchasers and 2 for non-purchasers who will not purchase. So this way we will be doing the analysis, like click on analyze, then go to classify and then go to discriminant analysis. So this dialog box will be open. So you have to put this in grouping variable and you have to define the range. Since we have given only 2 codes, 1 and 2 for buyers and non-buyers, and then you put all the independent variables here and you click on statistics. So we need means of all the independent variables say and say box sum method, and we know we need coefficients both standardized as well as non-standardized, and we click on OK. Then you go to classify, so all groups and within group OK, and we need to display the summary. You can also have case wise results as well. Click on that one. So you have to define the limits, otherwise limit case to first, or we need only summary table. Okay, click on OK, and what you have to save, we need to save these say to discriminant scores and predicted group membership, and then click on OK. No need of bootstrapping here, and click on OK. So this way you can see, we can see here, this is the analysis of processing summary. All 80%, 100% are available, 80 cases are there, no missing observation. Now this is the summary table, group statistics. You can see here purchase and would not purchase, these are the variables. So the mean for all the independent variable for purchasers and non-purchasers are these one. These are the standard deviations, and 40% are there to purchase and not to purchase. Okay, so now we can come to analysis 1, that is box test for equality of covariance matrix for different 2 groups, purchasers and non-purchasers. So a potential buyer purchase and would not purchase, rank 3 given to all, and pooling is 3. So here you can see a log discriminant value of the discriminant function. This is log discriminant. So it is 16.3 and 15.8, and for the pooled it is 16.4. Okay, now we come to test result, this box test. So here we see that it is significant, but it must be non-significant, because the variability in both the groups covariance should be same, but here covariance for both the purchasers and non-purchasers group are not same. Now we come to this eigenvalues. So it is 2.377, and there is only one function, first canonical discriminant function. It has not made any more function, because and canonical correlation is there 0.83. It means 84% correlation is there between the discriminant function and the independent variables. And what Wilkes lambda is saying that it is rejected, the null hypothesis is rejected. It means that this discriminant function is a good fit. Now these are the standardized coefficients, and these are structure matrix. You can see here for structure matrix, these are the coefficients, and for discriminant canonical function, these are the coefficients which we have seen. This is for the unstandardized, and you can use for the standardized as well. So here we can make a function z is equal to -3.4 plus this one into this x3, or say start here 0.063 into x1, this durability of the bike, plus 0.22. So on the basis of these, you just put the values of different observations, and you can classify it in different groups. So here you can see the centroids for both the discriminant classes are 1.5 and -1.5, and these are the classification. So there is no misclassification there, are correctly classified there. And these are the prior probabilities, you can say 50-50%. And obviously, if there are two groups, so prior probability will be 50%. And see here, these are the Fisher's linear discriminant function standardization for both the potential buyers as well as for non-potential buyers. So you can calculate the value of the discriminant function for putting these values for buyers and these for the non-buyers. And you can see here, this is the case-wise study, not need of it, but if you wish, then you can have for every observation what is the value of the discriminant function, and centroid is this one. It means above this one and below this one we will classify. We will classify the different groups. So this way you can classify the observations. Above this one 1.5, below this one -1.5. So this when different units are classified. These stars may be misclassified. So but here misclassified cases, these are misclassified cases they should be in different groups, but are misclassified in so this way we can calculate. So that is why the fitting is only almost 84%, you can see here. So that is why some of the observations are misclassified here through this discriminant function. So this way you can see here, we'll count the percentage. 33 will purchase and 7 will not purchase, and in would not purchase 1 is misclassified and 39 are classified correctly. So here in purchase group 7 are misclassified. So this way we can do the analysis in discriminant analysis. Now these are the observations which we have saved for purchasers and non-purchasers. Now we are using this for the 3 categories. So let me Another example for 3 classes discriminant analysis. So, okay, we are having here some, I mean, this example. Okay. So here we are having, say, 3 groups regarding the product quality buying in shopping mall. You can see here what we have. We have coded one for large quantity. We have made 3 classes. One large quantity, purchase in large quantity, purchase in medium quantity, purchase in low quantity. So we have coded 1, 2, 3 respectively. Now the independent variables here are family monthly income in rupees, perception towards shopping mall, and age of the family head. So perception have been taken in, I mean, say 100-point scale or say 10-point scale. Let us see, it has been taken in 100-point scale, and these are the income and these are the ages of the persons. So now we have taken these observations on 30 persons. So let me do the analysis in SPSS. So click on analyze, then go on classify and click on discriminant analysis. You just put categorical variable here, and so you have to define the group. 1 is minimum and 3 is maximum, and you put all the independent variables here. You click on statistics, so mean, them, Fishers, unstandardized, classify, say summary table, and save if you need, otherwise no need of it. So here you can see the output. 30 cases are there, 100% are available, no missing observation there. Now this is the descriptive statistics for all 3 groups. For all 3 are independent variables. The persons are group who purchase in large quantity, in medium quantity, in low quantity. These are the independent variables. Monthly income, perception towards shopping mall, and the age of the family head. So these are the means of this is family income mean for the group who purchase large quantity, and in there is 76.2 points out of 100 for the perception, and the average age for the head of the family is 46.9. These are the standard deviation, and these are the it means 10 persons are there in the group. Now for the medium quantity group, the average income is 49.4, 10 less than that one, almost 10.4. Perception is average 51.8, and the family head age is I mean almost 10 to 11 years more than that group, older to that one. These are the standard deviations, and 10 persons are there in the medium quantity. Now we come to low quantity, the family income in 38. So every time say see here paying capacity is reduced, and towards shopping mall the perception is very poor, 33.3 out of 100. And here the head of the family age, average age is 64. senior citizen. And these are the standard deviations, and 10% are there also in the low quantity group. And these are the, I mean, for total put together, these are the average standard deviation, and these are the average income, average perception, and the age average for all 30%. Now we come to box equality covariance matrix, and from here we can observe that the p value is 0.4, which is much more than 0.05. It means the covariance for all the three groups are same. And we can see here two discriminant functions have been made. Two discriminant functions having eigenvalue 5.4 and the next one 0.013. So here you can see here percentage of variance. The first one is explaining 99.8 and the another one is rest. So cumulative 99.8 and it is 100. So we can see here the canonical correlation is very high for the first discriminant function, 0.92. So 92% of the observations are correctly classified by this discriminant function. So now here Wilks lambda is significant for the first one and non-significant for the second one. So first one is correctly or truly fitted. Now these are the standardized discriminant function coefficient for discriminant function 1 and function 2. So we will be talking about the first one because it is correctly fitted and correctly classified, and these are the structure matrix. So you can see the values pooled together within the group, and here canonical discriminant function coefficient for unstandardized. So here we can make the discriminant function, say this z is equal to minus 2.214 plus this into x1 means family income plus this into perception towards x2 and minus this into x3, this value that is age of the family head, and these are the centroid. So here you can through these values we can select, we can classify on the basis of these observations to different groups, that is large quantity group, medium quantity purchasing group, and low quantity purchasing group. Now here no missing are actually excluded from the table. So now we come to, definitely since we are using three groups, so prior probability will be 1/3. And now these are the classification function coefficients for all groups. And now we come to this. So you can see here for large quantity all 10% are correctly classified. For medium 2 are misclassified, and for low it is 1 is misclassified. That is why 90% of the original group cases are correctly classified. So there is 10% of misclassification. So this way we can apply the discriminant analysis to any area of application. So now if you have any query, any question regarding it, so we will be discussing, otherwise it is finished today. So please, if you have any query, please ask. So organizers are, Dr. Yadav, you are requested to unmute the participants, please. इनोवा से रिलेटेड क्वेश्चंस कर सकते हैं hands on. How to ensure that all the independent factors will be influencing the dependent variables on the basis of the coefficients. What is the rate of impacting that? So that is why we calculate the coefficients. If it is very low, so we may leave that independent variable, say 0.000 something. So a very slow rate will be there to impact the dependent variable. There are so many, I mean, books. It is better to get, if you wish to, I mean, do the analysis in, say, SPSS, through SPSS. So search for a book, biostatistics book based on SPSS. Width, you can automatically, it will take 8 character. By default, it is given in SPSS. Nominal for the dependent variable, if you are, I mean, using the categorical data, qualitative data. Final inference is that 90% you have made a, I mean, discriminant function correctly, and some of the observations are misclassified there. So that is given. Actually, they should lie in, say, low purchase group, but one observation is lying in medium. So this way. Kindly send soft copy of the book related to statistical massive SPSS. I will have to search as well. So everything is given. You can call any file through here. You open say database new query, so you can import the files. You have been taught about these things, and you can edit the things. You can weave the things given here, and you can I mean, change the data, add, subtract, sort, and all type of things. You can merge the files there. You can transform the data, and main for statistical analysis, this is I mean, important. Analyze, and you can make the graphs here. So this way, all the, I mean, entities are there in SPSS. Okay, I
Sir,
think it
can
is
you
not
give some
displayed.
example for health data where we can apply discriminant analysis?
So suppose if you are, you have taken some example, say related to, I mean, say TB patient and non-TB patient. So you have taken some, I mean, vital parameters regarding the TB to the persons, and on the basis of that persons, you can discriminate them in 2 categories.
So finally, we want to know that all those parameters which we have studied, they help us to classify patient in TB and non.
Definitely, if suppose a new person is coming and you have made a discriminant function, and it is capable to explain correctly, say more than say 99 or 90%, or say this way. So if person comes with these vital parameters, and you just put them, because you are having the coefficients, and you will be capable to, you will be able to classify it in either of the group.
Okay, yeah. Thank you, sir.
Sir,
Yeah.
sir, there are three scales: nominal, ordinal, and scale and simple scale. Sir, when we have a data related to ratio and interval scale, then in which category we have to put that data? On
Scale,
scale?
scale
Yes.
is ratio and interval.
Okay, yes, sir.
And categorical is nominal, either nominal or ordinal.
Okay, sir. Okay.
If order is there to be considered, then you put it as ordinal, otherwise nominal.
Okay, sir. Okay, sir. And when to use scale? Sometime we put in scale form. So
If you are putting, you are changing, say, if you are taking observations of, say, nominal or say categorical variables, but you are doing them or getting the information, say 10-point scale, say Likert scale or 100-point scale, then you have to mark it as scale.
okay, okay, okay. Thank you, sir. Thank you, sir. Thank you.
Sir, for count data, dependent variable, usually we use Poisson regression, right? For count data.
Yeah.
Yes. What about the independent variable? Suppose the independent variable is also count data. Which model is better?
Independent variable is
Also count data.
here independent is count data.
Count data, yes.
Count data means you are using just discrete
Frequency data.
variable, discrete variable.
Yes. So I know, but what kind of regression is best?
Sir, what is the kind of dependent variable as well? Because in regression, there are two types of
dependent variable is
dependent
also count data. Dependent variable is also count data. So for that we use
you
Poisson
apply
distribution.
simple regression?
No, Poisson regression we use.
You are using Poisson regression.
Poisson regression, yes. And but confusing with the independent variable data. Suppose if it is a count data, what we use is the same Poisson, or do you have any other idea?
And dependent variable is a Poisson distribution.
No, dependent variable is count data. It's
Count
a count
data.
data, like frequencies, number of something.
Okay, so it is I mean ratio scale and ratio scale. And
but the regression model, what kind of regression we use?
if both the variables are this type numerical data,
yeah.
then we use simple regression, maybe linear, maybe non-linear.
But linear and non-linear are existing for continuous data only.
Continuous data, okay. So
but
categorical as such regression is not applied there for I mean
count data.
yeah.
Okay, thank you, sir.
Sir, my question is related to my study, which I am doing at present, not directly related to discriminant analysis. I just want to ask, hello?
Yeah.
That I am studying, suppose, vitamin D level in recurrent wheezing or allergic child. So how do, which study I have to apply that? I don't know. Actually, that is the most difficult question to choose, that which study I have to apply. Suppose it is significant, matlab, it is relevant or not relevant in recurrent wheezer, how can I come to know which study I have to apply?
So you apply discriminant analysis with the two group, say relevant or not relevant, and you have taken the measures on different parameters.
Sir, I am going to do vitamin D levels in all the children with recurrent wheezing. So my cohort is a patient with recurrent wheezing who have 2 or more episodes of wheezing, lower respiratory tract illness. Okay, and I am going to do vitamin D level in all the children. So now what I have to do, I have to like compare them with a normal mean vitamin D, suppose, or what to do, matlab?
If you are using a vitamin D, you are getting the observation on, say, quantitative data continuous, na?
Yes, sir. Vitamin D is quantitative data, continuous. Yes.
So you can, I mean, have a t-test with the healthier group one.
Then I have to take 2 group, na sir, healthier and weezer. But without taking like control group like healthy children, can I do it, matlab?
You should take healthy as control group, and you take the vitamin D deficiency group, another
That's
one.
what I'm asking. Okay, without taking sample from healthy group, can I do this study or I can't do? Matlab, just I want to take.
I am getting your point. You just wish to know the threshold point of.
Yes, sir. In visors, because sir, it is always difficult to get healthier group for testing at our level. That's why I'm asking this, sir.
So definitely you go for the descriptive statistics, and you see, and you just classify on the basis of, say, some parameters first, and you see what is the average for the two groups. Are you are just using, say, you are taking two groups, so on the basis of the deficiency. So without, I don't think without healthier person it is very hard to
Without
establish
healthier, it is difficult, no? Okay. Okay. So I can revise. I have to revise it maybe, or better to take healthier group, right?
definitely.
If it is your case control study, then
Yes,
you have to take one case, one control. Control means healthy groups.
Yeah.
Then only you can compare. No? Otherwise, you cannot say that vitamin D deficiency is going by because of this or because of that.
Okay, sir. Okay, sir. So definitely I'll include.
Unless we don't have control group, then we cannot say. We must have control group.
Without comparing, we will not be able to, I mean, give any statement.
Yeah.
Okay. Okay. Thank you so much, sir.
Hello.
Yeah.
Yeah. Thing is, just I have one clarification that is regarding the centroid. When you have a two classification or two groups, we have only one centroid. That is, one is plus and minus, right? But whereas when we have a three classification or three groups, and the dependent variable, but we have three centroids, right?
Yeah. Because we are having three threshold points.
Yeah, which threshold point should we use?
Above that, and in between and below that.
Yeah, which one, like, okay, first to categorize the first one threshold value we should use. And for second one, like, okay, why the second one? And the third one?
Third one maybe for the all group or let me see.
We had three centroid points. Yeah. I think you have taken only two groups, I think, here.
No, I have taken also a case of three groups.
Okay, three. Okay, fine.
No, there are only two.
No, this is, I think you have taken only for the two. This is not a three group. It's a purchase and would not purchase. Okay.
Okay, it is the case of only two classifications.
Two groups.
This is
Yeah. Yeah, here we have 3 centroids, right? Like one is for the large quantity, 2.8, or medium quantity.
Medium quantity 0.2.
Yeah, minus 0.2, and low quantity minus 2.5. So now which function would you use to categorize them?
These two should be used.
Okay.
First
So
and third.
first and third. Anything above 2.8 is a large quantity, right?
Third one, and below, above this one and below this one, and
second one, anything less than 2.8 would be a second category, and
Yeah.
anything less than 2.5 is the third category. Is it so?
Yeah.
Okay. Now, which function, the final function, which function should we use? Whether that is a discriminant function coefficient or function. Which
We should
function?
use
Because we have
unstandardized this function. We should use canonical discriminant function.
yeah.
Because
Then here we have 2 functions, right?
no, it is given here. First one is explaining more. I mean 92%.
Okay.
So we should use only first function.
First function only. Okay. Only first function should be used. Okay.
Yeah. Because it is capable to explain correctly, yeah, classify correctly 92% almost.
Yes, yes, okay. So in based on that, we have to use the function.
Yeah.
So that one still okay. Which the middle one, the centroid point.
Yes. Yeah.
What does that gives? Still have one question. Okay.
Yeah. Just tell me.
Yeah, that question I have. That centroid middle one. Where to use that one?
I don't think it is very much. You see here, it is very less value.
Yeah.
So maybe it may be the average or central value of that one. The average for all the say observations for the medium group quantity.
Okay.
So, but classification is clear. You take more than that, less than that, and in between.
And less than 2.5.
Yeah.
Less than 2.5 minus 2.5, third category.
Yeah.
Okay. And can we use something like homologous D here?
You can use, any by default here, some distance. No, distance measure is not used actually here. We have used the discriminant function. And that was used in cluster analysis.
Cluster analysis, yeah. Okay. So that is only for making a category, how many clusters we can have.
Yeah.
Homologous D can be used.
Yeah. We can use any distance measure there, Euclidean space, or say Manhattan, or say this Leibniz D square. We can use so many distance measures are there.
Okay, fine. Okay, thank you.
Okay. Any more questions?
Sir, there are questions in the chat box, so can you take those questions? Someone is asking.
अब बकवास मत करो कियांश।
So,
अब पापा कहाँ हैं? हम
kindly,
नहीं आएंगे, जाए अपना, हम खाना बनाए अभी दो गए। वहीं पे एक तरीके से करवा नहीं सकते उसको, बकवास कर रहे हैं क्या?
Dr. Sushil, sir.
Hello, sir. I'm Prachi Walking, sir. I have one question. I have prepared.
Yeah, you can write in the chat box.
Okay, sir.
What do you want to?
Your voice is not coming, so you can write in the chat box.
2 persons.
Sir, not a question, but a request that please arrange some other workshop like samples size calculation and how to research hypothesis on.
Yeah. So we are planning to conduct a workshop in the next month. That is for the biomedical research. So
Yes.
it will be the 1 week workshop on the biomedical research. So all the aspects of biomedical will be covered into that. So you can join.
Thank you.
So, ma'am, what is your specialization?
Sir, myself pediatrician. I'm working in Government Medical College here in Jamnagar, Gujarat.
Okay, that's nice. So we are conducting biomedical research as well as biostatistics.
Yes, sir.
So our next workshop will be in the month of February.
Sure,
so,
sir.
So we'll
Overall,
look
it's a
for the
nice
biomedical.
experience as we are very illiterate in form of statistics, I think. So
But
we
no,
just
no
know
need.
how to
We are here to serve people not having so much information regarding statistics. So that is why Dr. Yadav is there to conduct. I think every month or say alternative month or say in quarterly.
Yeah, actually we are serving to the researchers for the sensitization of statistical tools, so that they can apply exact or actual statistics into their research, so that ultimately the quality of research will improve.
Yes, definitely. Actually, we are we take help from a PSM department for
Yes,
our
yes.
dissertation statistic and all that. But many a times it happens that they exactly don't know what we want. Because we always think as a clinician and they think as a statistician. So
Yeah. So you have to bridge the gap. Actually, we
statistician in community medicine department, then he or she exactly will tell you which kind of test or which kind of study you should plan, type of study design and sample size.
But actually, what is happening, sir? We plan before asking.
Yeah.
We are telling them to analyze. So that's what.
Yeah. Actually, if you will involve the statistician before conducting your research, so that will give the exact guideline.
Actually, we don't have biostatistician. We have research assistant, but they also don't know exactly how to analyze and everything.
So to deal with such situations, ma'am, there is a suggestion. If you have any reference paper and you give to the statistician, and he or she will be capable to know that.
Sir, we are doing it, but always like a research question, we thought something different we have to do, because we are not doing similar study. We want to study something like different, not exactly similar. So many a time some confusion will happen, but definitely I think I'll plan to join next workshop.
Yeah. So that will be totally depend on the biomedical research. So how you formulate the study design or the sample size, and all these things will be covered, including like how you write your protocol, dissertation, and research proposal.
Actually, I have done that BCBR, but I don't know, somehow basic idea I'm getting, but that's not enough, I think.
No. In that workshop, we have experts from ICMR also, so they will tell you.
We can take few questions from chat box also.
Yeah, you can take this.
Yadav sir, can I ask one question?
Yeah, sure.
Yeah. Thing is, okay, this is not for of today's class. Okay. In regression analysis for the cohort studies, can we get a relative risk? Because odds ratio always it will be more. But if you want to get exactly the relative risk, is it possible in SPSS?
I will have to see it.
I don't.
Whether from logistic regression it is so or not. So
no. I don't think
whether
so.
we are capable to calculate the relative risk, because we will be.
Yes. Relative risk we cannot calculate.
But because odds ratio always it will be more.
Only odds ratio or adjusted odds ratio you can calculate.
Yeah, but it will be more. So how to overcome that one? Because when you have done the univariate analysis,
you have to go to cost step, apply cost step. There you can get some relative risk odds ratio and everything.
Yeah, but when you calculate adjusted odds ratio, it will be more.
In that case, you cannot. SPSS will not give you.
Yeah, that is the one.
On the basis of, I think, descriptive statistics, you will have to see the things.
Yeah.
By cost we can get,
Last
but
time you can apply there and percentage or say this way
while
you
adjusting
will
the odds ratio, we cannot get the relative risk and other things. No?
yeah.
That is
Actually,
the,
when
Yeah. One more thing, one more question, Dr. Yadav. Thing is, okay, in while analyzing in the linear regression, so all the independent variables, can we have the independent variables of categorical? And similarly, even in the logistic regression, can we have the independent variables which are continuous variable?
So in logistic regression, all the independent variables are continuous variables there. This is okay. Independent variable is categorical only.
Yeah.
And if independent variables are categorical and dependent is, I mean metric, so we apply ANOVA there.
Now, can all the independent variables should be categorical only in a logistic regression, or can we have even the continuous variable? That was my question.
you can have continuous also in logistic. We can have.
Like similarly, even in the linear regression.
You have to take the observation on 10-point scale or say this Likert scale. You put the observations.
Yeah. So is there any condition that so many variables can have a continuous variable as an independent variables? No, because if suppose if many continuous variables are there, it is very difficult to, or the regression analysis may not give a correct result. That is what my assumption.
Definitely. So that is why in such cases we move towards say non-parametric type analysis there.
Yeah.
But in non-parametric there is no option for this, I mean regression type.
Yeah. Okay. Thank you.
so sometimes while calculating the odds ratio or relative risk in through AP info, and when we are calculating with SPSS, the values are different.
Yeah, it depends on the, how much, this significant level of significance and other things you are taking into that. So there are, I think, some other questions for the cross-sectional survey study. Which test is applicable? Yeah. Point surveillance and impact analysis.
If you are dealing with the only categorical variables, those there is nothing to left then. I mean cross step, that is chi-square test will be applied there. And which type of study you are talking about?
It's talking about cross-sectional studies. So
cross-sectional studies are basically for the medical sciences basically. So logistic regression may be there, and these multivariate techniques will also be applied there. So it will depend on the hypothesis.
Yeah, what you really want to analyze.
Dummy variable is just used for say it is just like indicator variable type.
Sir, wanted to ask about some statistics to be applied for crossover study, a trial which we are doing. So basically, we are doing it in pediatric patients. So we are going to study the pain scores of children from 1 to 1 year of age, whom we will try 3 things in each case, with a minimum duration of 24 hours between the 2 interventions while doing a venipuncture. So before venipuncture, we will give them 10% of dextrose. Second time we give 24% dextrose, sucrose, and third time we give plain water to children. And then we measure their pain scores at the time of doing venipuncture, at 1 minute, at 3 minutes, at 5 minutes, and at the end of cry, when the child stops crying. So my basic question was, if my data is like normally distributed, so what tests can I apply?
So one thing you can apply the repeated measure ANOVA type there, and some factorial analysis will also be applicable there.
Okay, factorial analysis in the sense how can I do that, sir?
Because you are having different factors there. One is say pain score, and say another you are doing different timings, and you are using different say salts or different dosage. So this way you
Yes.
can apply it.
Okay, because the patients are same, because the group, there are 50 patients on which we are doing this, using everything on them. So for crossover study designs, is there any specific statistical measure which we need to take?
So this is the only way, because in factorial analysis we take the same unit and we apply different factors there at different levels. So you are using here different factors at different levels. So the factor analysis this I mean factorial analysis will be there. Factorial design will be applied there. And if you are making some say other variables as constant, say, then you can use repeated measure ANOVA there.
Okay. Yeah, so repeated measures ANOVA will be, for example, if I want to apply, I will have to apply for D 10%, then 24%, and then water group, and then compare them.
Definitely.
Yeah. Okay. Thank you, sir.
Sir?
Yeah.
Yeah. Sir, for a study, there are 2 exams, okay? And the results are either pass or fail. How we know which test is the best test?
Dr. Sushil, are you there? Dr. Singh?
Yes, I'm here, sir.
Yeah. So I think now we have to stop. Please make me co-host, or you can.
Yes, sir.
Some disturbance.
Mute everyone, please. No? Then.
So now I think.
Am I audible, sir? Hello?
Yes, please.
Yes, sir. I just want to one basic question. Sir, how can we calculate sample size? We have two is in quantitative research, two groups. One is control group and another is experimental group.
Yadav sir, you want to answer? Can you?
Actually, the voice is not clear. I was not able
So
to.
there are 2 groups, one experimental group and a control group, and he want to that sample size for how he can calculate the sample.
So
how
sample
to
size
calculate
calculation,
sample size.
if the person is, I mean, applying independent sample t-test, so there is prescribed formula there. You can calculate.
Yeah. Dear, first you have to identify your problem, whether it is quantitative problem or qualitative problem. It is
Definitely.
qualitative
So it is
type.
quantitative first.
Then you have
Okay.
to have this standard deviation and mean of both groups. Okay. Then there are formulas are there. You can apply and calculate the sample size. Okay. We will later we will have another workshop on this one.
Yeah,
So,
with the sample size we will cover in the biomedical workshop. So there is no issue. Because for every study there are different methods or formula for the sample size calculation.
yes. Yeah.
Even some
But-
softwares are also available into that. G star power is a very important software.
Power you can use.
G power is a very good. So I think now we have to stop today's session. And if any further queries, so that we have with you, our email ID is with you, so you can directly approach to us, and we will send you your answers. So it was really a nice journey to have all of you with us for last 1 week. I hope you all have enjoyed and get benefited from our resource person. So all the material like PPT and video will be sent on your email. And Dr. Singh, are you there?
Actually, we have not day one PPT. Kindly arrange day one PPT, sir. And
okay, no problem.
And day one and day 5, Gayatri Viskarma, Dr.
Okay.
Gayatri Viskarma.
No problem. So we will send that PPT also. Don't worry. So I think you have enjoyed and you have. So if any feedback from you, please share with us. You can write in the chat box or you can speak, or for the further improvement or further upcoming programs. So we will incorporate your suggestions.
Any participants, if you want to say about this workshop, so you can unmute yourself and share your views.
So it was a very good workshop. I'm hoping to attend more like this.
Thank you. And the next month we are going to conduct this biomedical workshop for the 1 week. So we will cover all the biomedical, aspects of biomedical research, including study design, testing of hypothesis, sample size calculation, and all these things. So you can join.
Hello, sir.
Yes.
Sir, I would like to suggest, sir, if we can make a group or something where you could update us on, various online workshops that you will be
Yes.
conducting.
We have a Telegram group, and after the completion of this live session, we will share the Telegram link, and kindly join that link, and we will update all the workshop FDP conference organized in this platform and various
Yes, sir. Yes, sir.
national and international institutions collaborations. And
Yes, sir, because-
Dr. Yadav has already told you, and we have planned 1 week online workshop on biomedical research.
Okay,
And
sir.
we will update you everything, sir.
Dr. Singh, you have mail IDs of our participants, so you can send the link for Telegram groups and WhatsApp group also.
Yes.
So they can
Yes.
join. No?
Yes.
So what is the status of certificate, Dr. Singh?
Certificate prepared, sir, and we will send the recording as well as the certificate simultaneously after this complete the sessions. And if any correction found by you, so kindly email to us, and we will correct your certificate, and we will revert back within a week. So you don't need to worry about the certificate corrections. If major corrections required by you, actually all the details filled by you during the registration time. So the data
So that will directly
by the registrations. Okay. So if correction found by you, don't worry. We will correct within a week.
Yeah, because it's automatically what you have filled in registration form, that will automatically take in your certificate.
And
sir,
I request you in for upcoming workshop, kindly fill the details very carefully, because it's
yes.
totally online system, and all the certificate and barcode and certificates generated automatically through the programming. So it's my personal request, kindly feed the data very carefully.
So I just want to say one thing.
Yes, yes.
So my email ID was wrong. So that is the reason why I was writing to Dr. Sushil Kumar Shukla, and so was sending me in the WhatsApp. So I was joining through the link which
There
I
are
got
few
through
few
WhatsApp.
email IDs wrong, okay, ma'am?
Yes.
And we detect those email ID, and I directly contact to him or her. I think we got the some of email ID, and some they didn't receive my phone. So if in your contacts, kindly say to him or her, please send the correct email ID. Actually,
yes.
some also written their wrong email ID.
Yes.
So they didn't get the correct information. Okay.
Dr. Singh.
Yes.
Is
Yes.
it is it possible right now we can share the link in chat box to everyone so that they
What?
can
They
link
will
up
copy
that
it and they will
Telegram.
save it.
No, they emailed our official email for Science Tech 487. So
Right
all
now,
the correction will be made.
also you can put here in
Okay,
chat
so
box.
the participants have given sir wrong email ID in the
They can chat box. They can write in chat box.
So, but
Hello,
if you have the right now that link, so you put
But
on the chat box.
we required official email ID because our staff working on back side. So they will. We are all here, but our technical staffs working on back side. So
Not an issue. Not an issue.
we need in email, sir.
Okay, fine.
Yes.
Hello.
Excuse me, sir.
Can I express some words, sir?
Yeah.
Yes.
Yeah.
Myself, Dr. Annapuri from Maharashtra. Last 7 days, really, I have enjoyed all these sessions with depth level. Actually, I am not the background of the statistics. I am another background, but still, whatever I have achieved, whatever I have got, which is really, sir, amazing. And I hope that in future, such type of excellent academic feast will be provided by you people, you community. It is one of the greatest and excellent online program. Thank you very much.
Thank
Sir,
you.
what are the dates for the upcoming workshop in February?
Upcoming workshop will start 21st February to 27th.
Okay, sir, I will.
Actually, most of program
follow.
which will start from 21st.
Sir,
in every month.
From all domain, from people, for example, I am from media studies. Can we join that workshop, or this is especially for biomedical students?
All the medical professionals, all the academicians who belong from the life science and biostatics,
social sciences, sir?
And
from social sciences.
Social sciences, if it is relevant for your research, then no problem, you can join.
Okay,
but
sir,
you
okay,
actually
please
sample size
check the content before the joining.
Yes.
Okay, sir. Okay, sir. Of course, sir. And thank you for organizing this workshop, sir. And one more request, sir. Please share all the PPTs of 7 days in one mail so that it would be helpful for us, sir. Thank you so much, sir. And thank you for this workshop, sir. Thank you so much.
Thank you for joining. So I think all the participants have enjoyed all the 7 sessions. So we are really thankful to our collaborating institute, especially Sushil sir. Sushil sir, are you there?
Yeah.
So we have. Please share some few words by you, Professor Sushil sir.
Because
so I thanks to all participants who have joined this workshop, and I hope that you have all learned many things by this workshop. I especially thanks to my Vice Chancellor, Dr. P.K. Singh sir, for giving me the opportunity, and special thanks to Dr. Sushil and Dharmen who has who organized this workshop with UPMS Safa. And I also thanks to all our eminent speakers who have spoken and who have taught very well to our students, our participants who learned by this workshop. Thank you all being with us for this whole week. And I congratulate all the organizers and thanks to all the organizing team members for this successful organizing of this workshop. Thank you. Thank you all. Thank you, Dr. Dharman.
Thank you, sir. Thank you for giving this opportunity and for this collaboration. And we hope it will continue in near future also, and the participants will get benefited from it.
Definitely.
Hello.
Yes.
I want to say, sir, how can I get a admission in Science Tech Institute for Masters and Higher Education?
It is not actually this is run by the MKS Education Society. All the academics work like the workshop trainings and their
Yeah,
their
no, it's not actually. It's
publications house and
educational.
if you want to admit, you can contact to in Sci-Fi Medical College.
Okay,
So
sir.
they provide many medical
yes.
programs. So with this now, I think Dr. Sushil, we have to say bye to all participants.
Bye to all.
And we see you in the next program. Thank you all. Thank you for being with us. So you will thank you all. Thank you all.
Thank you, Dr. SKS Karo, sir.
Thank you, sir. Thank you.
Thank
Bye-bye.
you.
Good night.
Thank you.
Thank you to all of you and bye-bye.
Good night.
Good night.
Good night.